The pinball launcher problem, this is one that was on an exam in 2016. And usually these problems have more than one step. So the way I've worded this problem is a little bit more complicated than it would be on your exam. They'd break it down step by step. But let's take a look at the theory behind this. So a pinball launcher, which has a spring and a mass, I just made an arbitrary 10 kilogram mass, is pulled back, and the elastic potential energy of the spring supplies kinetic energy to that object, which is going to then slide up a ramp. Okay, so you have inclined planes, you have gravitational potential energy. Look here, we got friction because there's a friction coefficient. All right, and the question says, calculate how many centimeters that spring needs to be pulled back in order to launch that object so that it makes it to the top of the ramp, just finishes at the top of the ramp. Okay, in that case, the total work done by the spring is going to be equal to the work done against gravity plus the work done against friction up that ramp. This portion here is frictionless, okay? So how would we set up the math to be able to calculate this? Well, we got to remember, how do I calculate the work done or the potential energy of a spring? Okay, the formula for that is 1/2 kx squared, where k is the k constant of a spring, the stiffness of it. X is the displacement, and that's kind of what we're looking for in the problem. We're trying to solve for x, right? And then how do I do work against gravity? Well, work against gravity is going to be mgh, assuming that we're on Earth. Okay, the acceleration of gravity is 9.81, 10 meters. That should be pretty good. We got the mass. All right, and then the last part is, how do I calculate the work done against friction on an inclined plane? So normally, the work done against friction is going to be the force of friction times the distance, okay, that it travels. Oh, now we got a problem. All right, we got to try to figure out a few different things, okay? I need to figure out what is the distance that it travels up this ramp. If that side is 10 meters, okay, and this angle here is 30, that's opposite, that's hypotenuse, okay? So we'd be able to calculate the total distance using trigonometry. And then how do I calculate the force of friction on an inclined plane? Well, the force of friction is equal to, let's rewrite this, Fn times mu times distance, okay, is my force of friction. Okay, Fn times mu times distance. Now remember, on an inclined plane, Fn is equal to, from a different video that we just made yesterday, it's cos theta. So cos theta times Fg is equal to Fn times mu times distance. Okay, so that's an important thing to remember about inclined planes. I'm just going to erase all this stuff up here. Okay, and I'm going to move this over here. Okay, so with all that, now we have all the algebra ready to do the plugging in of everything we want. So if we're trying to solve for x, let's move everything over. Okay, so whoops, x squared is equal to 2 times mgh plus cos 30 degrees times mg times mu times distance, okay, divided by k. All right, and then x, if I did everything right, is going to be the square root of all of this. That's nice. That made it quicker. Okay, so it's the square root of all of that. Okay, and then I'd have to plug things in. So how would I calculate the distance that it travels up the ramp? Well, that's going to be 10 meters divided by sine of 30, which is going to be 20 meters. So it travels 20 meters up. Okay, so then I would plug all these variables in. I'm not going to finish the problem. I'll let you guys finish it. But I'd put 20 meters here, 0.5, 9.81, 10 kilograms, cos of 30, all right, 10 kilograms, 9.81, 10 meters times 2 divided by 1,000, square root all of that, and that should give me x. Okay, so this is the logic. All I'm trying to present to you guys in these videos is how to set things up, the logic behind everything. Okay, so remember the distance, you'd have to use trigonometry to solve for that. And that's an opposite hypotenuse. So you'd have to do 10 divided by sine 30 would give you 20 meters, I believe. Okay, and then after all that, you would find out how much you'd have to pull back that spring. Okay, in the real IB exam, they would break things down for you. Okay, they would ask you to calculate that separately, or calculate that separately. And it would guide you through the solving of the problem.